The final part of chapter 3 that you will want to know how to do is create a box and whisker plot. Be able to read them and create them. The 5 number summary that you'll find in one variable statistics when you first found the mean, the standard deviation in one variable stats, it will give you these numbers, the min, the Q1, the median, and the Q3 and the max are the components of a box and whisker plot. And so I am going to ask you to be able to sketch these out by hand. So I'm going to try to do an example of that in this video. So, sorry, I'm getting a little glitchy with my newfound technology. So here are the descriptions of what those things are, Q1, Q2, Q3. I took out the part of this lesson that talked about percentiles because the main points of this last part of chapter 3 are the z-scores and the box plots. But what the box plot does is it does separate the data into quartiles because it'll take a set of so many numbers and break them up into 4 groups of equal amounts of numbers of data. The median separates data from the lowest 50% to the upper 50%. And so if I was thinking of 0 to 100%, what the median does is it tells you where 50% of the data is. But what you are going to be referencing is a number line. So anyway, Q1, Q2, and Q3 are the way that we separate the data. This is an example of a box and whisker plot. And instead of referring to these as Q1, median, and Q3, you see they use the word quartile, and that's what the Q stands for, quartile. And quartiles, when you know, like a quarter is 1/4. And so 1/4 of the data lies in this zone. That's between 5 and 10. 1/4 of the data is equally spaced from 10 to 15, right? And then you have data that's spaced between 17 and 20, but there are an equal number of numbers of values that are squeezed in there. So you might have like 1, 2, 3 numbers that are spread out, 1, 2, 3 numbers that are spread out, 1, 2, 3 numbers that are closer together, and then 1, 2, 3 numbers. So these little dots, kind of like a dot plot, that's what a box and whisker does, is it takes an equal amount of values, and then it tells you how far spread they are. So I'll go back to the first example where we talked about the median, and it was related to how long people would wait in a line for a ride. And this was the median because if you arrange the numbers from least to greatest, and you counted how many numbers there were, 35 was the middle number. But if I was looking at a number line, which is what a box plot does, and I didn't want to put every single number like 20, 21, 22, 22, right? It would make sense for me to count by 5s in this case. So 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75. When you're constructing these on your own, you want to think of something that you can count by that is going to get you from the min to the max. So that would be where I would start when you make your box plot, is arrange the numbers from least to greatest, and then the lowest value is one end of the whisker, and then the greatest value, called the max, is the other end of the whisker. Now the box is created by the median being the middle of the box. So 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, And so 35 is right here on the number line. That would be the middle of the box. Now, the Q1 is basically the median of the first half of the data. So this is the lower half, and this is the upper half. And you can't, you have equal groups now. There are 5 numbers. And so the median of the upper half of the data would be the middle number of these 5. That's your Q1. And 25 is right here on the number line. And then the middle number of this data is the median of the upper half of the data, and that's where you would draw the other side of the box. So, you know, when you read a box plot, you don't know how many numbers were used. When you actually see the data, you could tell, oh, the reason why this box is spread, this side of the box is spread from 35 to 50, it has to do with these numbers. And the 50 to 75 really was just those numbers, but the fact that 75 was so far out there, it made that whisker longer. So you don't have to generate these from scratch. You don't need the calculator to create the box plot for you, because I'm going to ask you to do what I just did there, is create it by hand. And the thing that you want the calculator to generate for you is this 5-number summary. So I'll give you a list of data, and then you can put it in and you do your 1 variable stat, and that's how you'll get the numbers to create your box. So it goes min, Q1, median, Q3, close the box, max is the last whisker. So creating the box plot's one thing I want you to do, but also being able to read a box plot is another thing that I want you to do. If you have some kind of skew, what you're going to see is the median to the one of the whiskers is going to be longer, and the longer the whisker, that's where the skew is. So this is skewed right because you have a long whisker on the right side. Normal distribution, because everything's all symmetric, is the 2 sides of the box will be of equal width, and then the length of the whiskers will also be equal. And I did get this from your textbook, but if it's a uniform distribution, you know, it depends on the data, so this is probably as best as they could get it. But what I like to show as an example of uniform is really if it's a little bit straighter. And so I won't ask you about that one. And so what I want you to be able to read is if you have skewed data in a box plot, one of the whiskers will be longer. And so from the normal distribution and from the uniform distribution, the box plot doesn't really help you so much with the shape. You just know that the spread is equal-ish. What comes up when we cover box plots is they offer us a way to quantify what is far away. So you've had to generally describe that an outlier is something that's far away. When this girl cheated, right, that this score was a fake score. But again, that right now for you, you haven't had to define what an outlier was more than it's just far away. But when you study box plots, they refer to the range of the box as the interquartile range. So this is Q1, this is Q2, this is Q3. And so the range is when you take max. Regular range is when you take the max minus the min. And then the interquartile range, the IQR, is when you take the Q3 and you subtract the Q1. So it hones in on the middle 50%. And so what is deemed an outlier is if a value is 1.5 times the interquartile range, greater than the Q3, it's defined as an outlier. Or if you go in the other direction, it's also defined as an outlier. I'm not going to ask you to be that specific. There are a couple homework questions that will do that. And so you can choose to include or not include them in creating the box, but you should never throw them out completely. And what you should do instead, if you don't want to include them in your box plot, is just put like a little asterisk or something. And you can choose to have StatCrunch create a modified. I am not testing this. It's just a thing about box plots that would be interesting to learn. So there you go. End of chapter 3. Good luck on the homework, and don't forget I'm here for questions.